So very good afternoon to everybody. This is an introductory video about one of the core environment engineering courses which is a part of our undergraduate program in civil engineering, and this course relates to water and wastewater treatment. So as the name suggests, it is a course. I'm handling this course from last few semesters, and I belongs to environment engineering from last 38 years. I'm doing teaching in environment engineering. This course is in two parts, covering both water supply management for municipal purposes like drinking, bathing, cooking, washing, and all municipal purposes. And then after the use, when the water ends up in a sewer line, then it should be collected properly because it is very obnoxious. It contains large number of pollutants, and then it has to be treated. And after the treatment, either it is disposed of or either it is reused. Now, before reuse, we should have an idea about the requirement of the water. It is needless to mention about that how much the water is needed. After air, the most important thing for the survival of living beings is water. Now, apparently, it looks that the water is available around us in a very large quantity, in abundance, but in actual very small quantity of the water. If you look at this say chart, you will find that out of the total water available, only 3% fresh water is available to us. And in the whole world, 47% of the population, which accounts to about 3.6 billion people, their water is scarce, where the water is not easily available. And there are number of factors, and one of the most important factors is that the water is the users of the water. The population is increasing at a very fast rate. We can have a very good idea that at the time of the birth of the Prophet Jesus Christ, peace be upon him, was 250 million, and it took 1650 years to get it double to 500 million. And the next doubling time is just 200 years, and the next doubling time is 85 years, and then say 80 years, then 45. So means that after every 40-50 years our population is getting doubled, and the quantity of the water is same. And it is not only that the users are increasing. With development, our say water consumption, per capita water consumption is increasing. So together with these factors, there is a compounding fact on the use of the water by an individual. In Saudi Arabia, there is a specific concern with respect to the water, because this is one country which doesn't have a perennial source of river water. Regular source is not available. So we solely dependent on either the groundwater or the sea water, which is converted. Now, sea water is available in large quantity in sea, but the sea water is very expensive water. It is energy extensive, and it is the incurred cost is very high. In Saudi Arabia, roughly 55% or more than 55% is the desalinated water we use, and the remaining water is the groundwater, and a very minuscule quantity we use as a surface water, either in the south part of the country or at some few places. Now, that water is directly linked to our health. Just to have an idea, about 250 million cases are reported with respect to health because of the water. And out of that, every year there are 10 million deaths. 10 million is a very large number. This is the biggest reason of deaths, and it is because of the poor quality of the water. Now, from engineering point of view, if you'll see that what we do, that we collect the wastewater from a source, we pump it, we store it, and then we check it what quality of the water is that, and we find certain impurities, then we remove certain impurities in a treatment process. This is a treatment plant, and then it is pumped and distributed in a city where this distribution network is shown in a very simplified diagram. after the use, roughly 70 to 80% of the water is converted into wastewater and ends up in a sewer line. So we have to lay a proper sewer line in a city parallel to this, and this sewer line is basically collects the wastewater and then it goes to a treatment plant because it contains a very large number of impurities. Now this is the basic structure of the course. So the learning outcomes and objectives of the course are these, that there are 3 outcomes, that we have to review the standards of different impurities, physical, chemical and biological, and then we have to design facilities for the water treatment and for the wastewater treatment, and finally we should know and we should have an idea that how those facilities can be evaluated. These are the outcome of the course. Now this is a simplified diagram of a groundwater treatment system or a surface water treatment system. That water is taken, pumped, then aeration is done for the removal of the gases, then some chemicals are dosed, and turbidity or small quantity of the suspended solids, they have been settled, then filtration is being done. If we want to remove the soluble solids also, then we may go for reverse osmosis, then we can go for ion exchange, and then finally we will go for the killing of the bacteria, that is called disinfection. So this is basically a train of the treatment of water for municipal purposes, for drinking purposes. Now after this the water is converted. You see that this is the wastewater, and when we settles, you see that lots of material either float on the surface or settles at the bottom. So this is a very bad quality of the water. It is ready to decompose, it is ready to oxidize, bacteria can grow in it, vectors can grow in it, and there are different effects. For example, if toxic materials in there, then they will kill the living living beings in the rivers, and they will also cause sedimentation of the suspended materials which are responsible for flooding. Flooding is a major reasons of human life and property loss. Then they may also cause epidemics, right, health related issues. Then you see that the objective is that this is the wastewater and we want to get it clean to this level, and these are the real pictures, that this is achievable if we properly do it, and we can convert the wastewater into a good quality of the water which can be reused. And there is a treatment mechanism. You see that you have to go for sedimentation, you have to go for biological treatment, you have to go for disinfection. These are the various treatment methods which we handle in this course. 448 is the number of the course, and these are the Saudi Arabian standards. Now standards varies from place to place, from the country to country, and we have to meet these standards. One are the standards for simple disposal, and another standards are to make it water fit for reuse purposes. Now as per the Saudi government's vision 2030, recovery and reuse and reclamation of the water from the wastewater is one of an important objective and a goal, that whatever wastewater we generate, entire amount of the wastewater is collected and reused for various purposes. So hope that those students who will join this course, they will be having a fairly good idea about the component of this program and will help you in your future life. Thank you very much.